Patients with phenylketonuria (PKU), a rare metabolic disorder, adhere to a special, and severe, diet throughout their lives. PKU patients are unable to metabolize phenylalanine, Phe, an essential amino acid. Without intervention, Phe from the diet builds up in the body. The accumulation can lead to intellectual disability, seizures, and irreversible brain damage. Treatment involves a strict diet with very little protein. Foods such as meat, eggs, and fish are off the table. So are nuts, beans, peas, and chocolate. To get enough nutrients, patients supplement with a Phe-free formula. As the years pass, many patients have difficulty sticking to the diet. Families and patients repeatedly tell us they need more options to effectively live with their disease, Puurunen said. This study is a small step towards potentially providing a new approach. Newborn screening identifies patients with phenylketonuria, a rare metabolic disorder. They also equipped the microorganism with a high-affinity Phe transporter to shuttle Phe into the microbe. To keep the bacterium from growing inside patients' bodies, the team deleted an enzyme necessary for bacterial replication. In preclinical research in mice and monkeys, the engineered bacterium, called SYNB 1618, reduced levels of Phe in the blood, even when the animals consumed protein and faced Phe ingestion. The results paved the way for new research published in Nature Metabolism. Puurunen and her colleagues conducted a placebo-controlled, randomized, double-blind study to test dosing and safety in PKU patients and healthy volunteers. We wanted to understand if SYNB 1618 was active in the GI tract of healthy volunteers and patients, Puurunen said. Was it chewing up the Phe and producing the metabolites we expected? The researchers administered the probiotic to healthy volunteers and PKU patients as a single dose or 3 times per day for up to 7 days. They found that the synthetic probiotic indeed chewed up Phe. Phe metabolites rose in a dose-dependent manner in blood plasma samples from treated subjects, but not in those given a placebo. Patients and healthy volunteers tolerated the treatment well. The most common side effects were GI-related, including nausea, diarrhea, gas, and headaches, and most were mild. All patients cleared the probiotic within 4 days after the last dose. This first-in-human study with SYNB 1618 demonstrates that a genetically engineered probiotic has the potential to address an unmet therapeutic need in a metabolic disease, Puurunen said. The basic demonstration is a significant step forward. Adam Arkin, a bioengineer at the University of California, Berkeley, who was not involved with the research, wrote in an email. It shows basic safety and tolerability. The team is now developing a next-generation strain that is more potent, and they are beginning phase 1 trials. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.